Alright, assignment 7, here we go. So here's the wheel diagram, so the forces that are on it, free body diagram. So you got the weight of the wheel, the normal force at point C, the force of friction at point C, the horizontal, and you got the pin, so the X component of the pin and the Y component of the pin right here, as well as the overall force of the pin. Of course, the angular velocity. So here I calculated the angle between the pin, the X and Y components of the pin, which is right here, 36.9 degrees. So let's get the components in the Y direction. So force Y is equal to MA of the Y. So the Y direction, you've got the normal force going up, plus the force of this in the Y, which is also going up, and minus the weight. Is equal to 0, since there's no acceleration in the Y or anything. You can simplify that, get FABY, which is this, and the weight, which I calculated up here. Is equal to 0, that's equation 1. And there's equation 2, which is force in the X. So in the X, you've got your force of friction in the X, which is the force of friction of C. It's going this way. And you've got your force of AB in the X, which is going the other way, that's minus. You can simplify this force of friction. The equation is U, the normal force of C, so 0.5 mc minus FAB equals 36.9 equals 0. So that's equation 2 for the direction of the Y. Then you got the moments. So the moment's going to be the moment of inertia. For equation, the moment of inertia times angular acceleration. So let's see, the moment's going to be the force of friction times the radius, which is 0.2 of the wheel. And you got the moment of inertia times the angular acceleration, so it's negative because it's moving in a clockwise direction. And you can just calculate that. The moment of inertia is going to be IB times MR squared. It's going to be K, so you can calculate that. 25 times 0.15, I believe. And that'll give you the moment of inertia right here. And that is equation 3. Simplify it a little bit. And then you got to solve for the unknowns. So I already did that on right here. I solved for all the unknowns. Here's the work. But yeah. So here's the unknowns: the force of AB, the components in the X direction, 88.2 newtons, and the Y direction for the pins, 66.2. The angular acceleration and the normal force. So then you want to get the time. And the time is using this equation for constant angular acceleration equation. So since this one stops, which means it's going to be 0, because that's angular velocity of stops plus the initial 40 is given, and we solve for this. Solve for t, you get it'll stop after 1.28 seconds. Okay, so part B, how would I redesign improve the design of the wheelchair for elderly users? So here's some ideas, I guess. Some ideas. Well, it's kind of weird how, this thing is directly, I'm assuming it'll be, the wheelchair is going straight into there. That's kind of weird. That's not really how a wheelchair would go. And this seems like it requires too much force. It requires 176, 110 newtons of force to go from there to there. That seems a lot, like for old people. And you're getting two of these, so that's like 220 or so. So you probably want to shorten this, I guess, and make it more ergonomic, since it's just it's like an L shape. Make it more ergonomic, make it like a diagonal or something. Maybe attach it directly. Yeah, there's some ideas to design it. Yep. Okay, thank you.